This slide deck is an introduction to concepts of exposure and dose and calculations that involve them. The learning objectives are for you to be conversant about the distinctions and similarities among exposure concentrations and various forms of dose. Another learning objective is for you to be able to convert between various units of exposure and dose. The related readings we've referred to several times already. The Heights book, Simple Tool Skills chapter, and the guidelines for exposure assessment from EPA. So today, in this recording, we're going to be focusing on this highlighted portion of the environmental health paradigm, going from concentrations to and those units to metrics for exposure, and actually we're on the way to internal dose. Okay. So let's talk about dose, because in a prior recording we examined exposure concentrations extensively, and we were introduced to exposure factors. So we're going to look at exposure factors a little more closely today, and these distinctions for different types of dose. Okay, starting with what is a dose? Typically, it's defined as a quantity of some stressor that enters the body, although it could even be a quantity that's on the skin of the body in the case of like a dermal irritant. Dose may be an amount, like milligrams. It could be a mass flow rate, like milligrams per day into the body, or it could be a body weight normalized mass flow rate, like milligrams per kilogram body weight per day, mgs per kigs per day. That's sometimes is how people refer to milligram per kilogram per day. So that's what dose is, generally speaking. Now, in environmental health, we typically recognized a few different stages of dose, and you might find these described with different terms in different publications in different places. I'm using here the definitions that US EPA puts forth in its guidelines for exposure assessment. Okay, so it starts with potential dose, which is the amount of the contaminant inhaled or ingested. So that could be, going up above here, like a flow rate, milligrams inhaled per day, milligrams ingested per day. Now, if we divide it through by the body weight to kind of scale to the size of an organism, that would be a constant value, the body weight, at least for a given point in time. And we would, like a fixed value, and so then we just have milligrams per kilogram per day. Right? So what is this potential dose, and how does it differ from the exposure concentration? It differs in this way. We're taking the exposure concentration and we're combining it with some intake rate, like an inhalation rate, an ingestion rate, and the result of that combination is this potential dose. Now, after potential dose, and so here's an example for exposure through a respiratory route here in the diagram below. I have an exposure concentration here, and just on the other side of that line is the potential dose. So going from concentration in the atmosphere to which a person, where a person's also present, and we incorporate their intake rate of air, their inhalation rate, and now we have potential dose. Applied dose is the next step in dosimetry, and it is defined as the amount of contaminant at the absorption barrier. So for the airways, that absorption barrier would be the respiratory tract. For ingestion, that absorption barrier would be the GI tract, right? And for skin, well, it would be the skin. So For the GI tract, the applied dose is usually pretty much the same as the potential dose, because once it's in the GI tract, there it is, and the GI system is working on that substance. Right? There's absorption, passage to the kidney or to the bile, and the like. The respiratory tract is a little different because only a fraction of the air that we inhale in each breath actually makes its way to the alveoli, and the rest of it is exhaled. So that's called the tidal volume, and you can learn more about that in a physiology class. In skin is a little interesting too, because to think about for absorption or contact with the skin or absorption through the skin, you have to think about the amount of material, the amount of the substance of interest that's actually in contact with the skin. So if it's like a sunscreen, SPF 50 or something, and you're applying that and you rub it in, well, the applied dose is the same as the potential dose. But if it wasn't that, it was more like say mud, right? Like wet dirt, and that contained lead, right? Just to do something in, and you put this, and maybe it's a child playing with the playing in the mud, and they end up with mud kind of caked onto their arm or their hands, and it's in a layer, and that layer has some thickness to it. Well, only the bottom of that layer is actually in contact with the skin. So the potential dose could be all of the lead in the soil that's on the body, right? It's like caked onto the body. But the applied dose would just be that bottommost portion of that layer of mud that contains the lead that's actually in contact with the skin. So that's a couple examples. So the distinction between applied dose and potential dose. Internal dose is the amount of contaminant that gets past the exchange boundary, so it's like been absorbed. And the biologically effective dose is the amount that interacts with the target tissues inside the body. That has to do with distribution within the body, metabolism within the body, elimination pathways in the body, and we'll talk about that in the context of compartment models later in the term. Okay. Here's two other figures, one for the oral route and one for the dermal route. These are quite similar to the figures for inhalation. I leave them for you to study.